Right. So this question was asked in CBSE board exam in the year 2024. We'll take a look at the question. The traffic police has installed an overspeed violation detection OSVD system at various locations in the city. These cameras can capture a speeding vehicle from a distance of 300 meters and can even function in the dark. So the diagram is given. So camera is seen. It is seen at a distance. It is seen at a height from the ground level. It is installed on a pole at the height of 5 meters. It can detect a car traveling away from the pole at the speed of 20 meters per second. So as you can see in the diagram, the speeding car moves away from the pole, and the most important part here is the height of the pole is a constant. It's 5 meters. It is given already. It's a constant. What changes is the distance between the car and the pole. And it is also given the question at any point x meters away from the base of the pole, the angle of elevation of the speed camera from the car is theta. So if you recall the concepts of angle of elevation, it is angle of elevation is when the object at a height is observed from a lower level. So the object at a height here is the camera, and it is observed from the car's level. And this angle of elevation, we don't know that is theta. So here there are two variables. One is the distance between the car and the pole is x, and that varies as the car moves up away from the pole. X varies, and as x varies, because it forms a triangle, right? So as x can vary, so the theta, the angle of elevation of the camera, can also vary. And theta here is dependent on x. It is not dependent on the h because it is a constant. H does not vary. H is a constant. So on the basis of the above information, answer the following questions. Express theta in terms of height of the camera installed on the pole. So I've drawn a triangle here. So this will be theta, and this will be the distance between the car and the pole, and this distance is 5 meters constant. So theta is given angle of elevation of the car, of the camera. So tan theta is equal to 5 divided by x. Theta is equal to tan inverse of 5 divided by x. So they've asked us to write theta in terms of height of the camera. That's 5. We have written that, and x. So find d theta by. So we have answered the first question. The second question is d theta divided by dx. If you differentiate tan inverse function, it is 1 divided by 1 plus whatever is inside the brackets. So 1 plus 5 by x whole square into, so as per chain rule, you need to differentiate the inner function also. If you differentiate 5 by x, you will get 5 minus 5 divided by x square. So that is equal to x square on top divided by 5 square plus 5 square plus x rather, x square times minus 5 divided by x square, cancel. So it becomes minus 5 divided by x square plus 25. That is the rate of change of angle of elevation with respect to x. Now, in the next question, they're asking us to, they're asking us rate of change of angle of elevation with respect to not just x, with respect to time. So there's a difference. What we have already found out is d theta by dx, rate of change of theta with respect to the distance x. Whereas in the third question, they're asking us to find d theta with respect to change in time. So we can use chain rule here, d theta by dx. We don't have to go anywhere for this. We have just found out this answer. And dx by dt. If you observe closely, dx is what is dx? Change of the displacement. Rate of change of displacement is Nothing but the speed, and that speed is given in the question, 20 meter per second. So it is minus 5 divided by x square plus 25 times 20. So that is equal to minus 100. In place of x, I'm going to substitute 50 because that is the instantaneous value of x. So we need to find the rate of change of angle of elevation with respect to time when the car is at a particular instant of x, and that x value is 50. So 50 square plus 25. So the answer is minus 100 divided by 2, 2, 5 and 2, 5. If you simplify this, you will get minus, both are divisible by 25. So you can divide by 25 on top and bottom. So it becomes minus 4 divided by 101 radian per second, because I'm using the unit radian per second because the next question talks about rate of change of angle of elevation in terms of radian per second. So I'm using, for the third subdivision, d theta by dt is equal to minus 4 divided by 101 radian per second. For the fourth subdivision, the rate of change of angle of elevation with respect to time of another car at a distance of 50 meters. Okay, so see, we need to find the speed of the car, and the speed is definitely going to be different. That's because the rate of change of angle of elevation is different. Because in the previous question, we got it as 4 by 101. In this question, we are getting it as 3 by 101. And also, I'm going to take this as minus 3 by 101 because I'm assuming that the car is moving away from the pole. Okay. So for this question, since the angle of elevation is different, the speed of the car is also different. So I'm going to find that out now. Using the same d theta by dt is equal to d theta by dx times dx by dt. And in place of d theta by dt, I'm going to use, in this case, 3 by 101 and minus 3 rather, minus 3 by 101, that's equal to, what is d theta by dx? So that's minus 5 divided by x square, and x is the same, just like in the previous question. So x is the same, 2005, x is 50, so x square is 2500 plus 25. I'm using this same value d theta by dx into dx by dt. dx by dt, we don't know. I'm going to replace dx by dt with the speed of the car. So if you cancel the negative signs, and then you can take 101 common out. So it becomes 5 into 25. That's because 2525, you can take 101 common out. So 3 divided by 101, you can cancel this 101 and 101. Now the speed becomes 5, and 25 also can be cancelled. Speed is equal to 3 times of 5. So that's 15 meter per second. So is the meter per second given in the question? Yes. 20 meter per second was the speed of the previous case. 15 meter per second is the speed of this particular case. And hence we have solved all the 4 questions.